Okay, let's go ahead and get started. Everyone, my name is Steve Bowles, and I manage our RPA technology partners here at Effisoft. In this webinar, I'll discuss how you can enhance your digital workforce document vision through 4 essential keys. By using the right document intelligence platform, I'll show you how we can improve robot automation and overall efficiency. Before we get started, a quick overview of Effisoft. If you aren't familiar with us, we help you create actionable information from unstructured document chaos. It's through this that we provide structured order and finally data to enlighten your organization. So it's interesting that one of today's most advanced process automation technologies, software robots, are broadly using decades-old technology in its simplest form to drive document automation. Smart Capture platforms can go beyond basic OCR, augmenting your RPA efforts and enhancing robot vision. Before we see the solution, let's examine the current state and the problem. So every organization today has document pain, either with physical documents, digital documents, or most probably both. In the world of RPA, document-centric processes can be a target. But to process documents and the unstructured content within, bots need clear, unobstructed vision to analyze document streams, make intelligent decisions based on the data, and request help from humans if required. The Everest Group put out a great report on RPA called the Smart RPA Enterprise Playbook. So by enhancing robot document vision, there can be a multiplier effect. When you examine difficult enterprise document workflows, where just a minor enhancement or improvement can dramatically impact a wide variety of the factors that we see here on this list. If we look at a typical organization, they receive documents from a wide variety of sources on a daily basis. This typically creates a multi-channel problem, and organizations struggle creating a streamlined flow for physical and digital documents, let alone one from fax, scanners, copiers, mobile, email. Well, you get the picture. In processing, humans typically have a variety of workflows, both manual and automated, to go through inbound documents. Some may augment and automate a piece of this with technology, but the core concepts still remain. Documents are received, ID'd, separated, sorted, and routed. Important data is identified. Data is extracted and entered. And then data and documents may be validated, although this step is missing in quite a bit of organizations, which causes additional problems. Hopefully, in the end, the data and documents land in the correct system. If we just swap out people with robots without enhancing vision and relying on legacy OCR, we essentially create digital confusion, as bots have no way to accomplish all these document processing steps and just don't have the intelligence to handle the flow. Outfitting our robots with dirty glasses can be an inhibitor to maximizing efficiency and achieving peak automation. So what are the roadblocks? The majority of the OCR engines on the market are 10 to 12-year-old technologies and are quite good at what they're designed to do, just convert images to text. But understand that the OCR text results are the baseline or foundation for the document processing methods. There's no context, there's no identification of type, and there's no data of interest right out of the box. Many products take that text layer and provide basic pattern matching, use templates, or OCR zoning to extract data. These technologies are ineffective with semi-structured and unstructured content, can cause high error rates when trying to classify, and really require high levels of human involvement in exceptions processing. Added intelligence is just necessary to aid in full automation. With complex workflows that take RPA implementations to the next level, to avoid digital workforce confusion and high exceptions rate, we need a smarter platform. If you take a peek again at Everest's playbook, Smart RPA is reliant on the intermingling of a wide variety of augmenting technologies that make the digital workforce smarter, faster, more accurate, and less prone to human involvement. From a document processing perspective, combining robotics, an intelligent document vision platform, and machine learning can improve efficiency, maximize digital workforce productivity, and help you reach the highest levels of automation. Now that we have an understanding of the issue and what we need to get maximum results, what are some keys for improving robot document awareness? I'll touch on 4 essential areas that must be part of your clear robot vision strategy. The first key is that we have to go beyond basic legacy OCR and adopt a Smart Capture platform to enhance our vision. Modern Smart Capture platforms don't look at documents as pure text, but as a series of dimensions. Looking at documents in this manner enhances our accuracy and leads to desired results. It also allows for advanced methods of extraction that go beyond pure text matching. These enhanced extraction rules allow us to move away from rigid processing templates and provide for variations in documents and rules that it can apply across the corpus. Advanced platforms extend our processing reach to more complicated document types as well. The second key requirement is machine learning. ML provides simplified setup through the use of sample documents. Upload your different document types, and the system builds a model for identification and classification. Along with simplified setup for admins, ML also provides a training mechanism for operators, both digital and human, where items that aren't recognized can be added to aid the next time that type is processed. Documents are difficult and can't be treated like any other image. In my experience, there can be document form types that look exactly the same, except for a minor difference in formatting or text. Most of the ML models that work well in identifying images of a lion or a dog just won't pick up subtle dimensional details. So doing a combination of text analysis and a possible layered approach is required to meet our goals. Analyzing beyond the image or text is a strong requirement and key, and the document intelligence leveraged by the digital workforce needs to focus on document dimensions beyond plain words. The third key is what I like to call the 3 pillars of document capture. Essentially, the following 3 slides are the digital equivalent to what a human document processor does in their day-to-day work. The first and most important pillar is classification. So just as a human knowledge worker would examine the documents, the system applies its learned model to figure out when one document ends and another begins. It auto-classifies or identifies the document type and all the pages contained within. This function allows documents to be captured in bulk bundles, such as large PDFs or paper stacks, and does all the heavy lifting in short order that would take a human worker extensive time and effort. Once the system's identified all the documents in the train of pages it receives, it then rips them into individual sets. This process is similar to the task a human would perform on a stack of documents that need to be split. In the digital world, it's called separation. So separation provides the ability to output individual documents as the end result of a process. When you combine classification and separation in this automated form, using your machine learned model, you create massive time savings and efficiency, especially when dealing with large multi-document PDFs or large volumes of incoming paper files. This combined process also preps the documents for the next automated step. Manual data entry is the next human process we can tackle. Through the use of rule sets tied to our classification, we can now auto-extract data of interest from the document. These rules can differ and vary per document, and the technology eliminates the need for a worker to manually enter data, manually name a document, or even manually create folders on the system. This data is now available to the digital worker for further processing and analysis. The last key is that robots need a what I call phone a friend option. But when human intervention is required for an exception, it needs to be a controlled and seamless evolution. To validate and process exceptions, humans and robots need as much information as possible. With Smart Capture, rules can be built to catch documents missing pages, data that's low quality, and also data that doesn't match what the machine or robot expects. This process of validation and exceptions processing can eliminate errant data, format information, and ensure high quality. Note, this is the only step that requires human intervention, and these cues can be used to train the system for further use through an easy-to-use machine learning interface. With the right technology, we can create what I call a robot sandwich. This method essentially has a software robot as a source of the documents, feeding the document process, with the ability to engage human knowledge workers for quality assurance and/or exceptions processing. At the end of the process is another robot waiting for the results. Once again, a simple, seamless method and interface to get input from humans. So where can we find those 4 key elements? Effisoft provides those and more to give your digital workforce clear document vision. To put this in even simpler terms, and in the context of a robotic workflow, we open up robot vision to unstructured content and documents, providing classification of doc types, separation of bundled PDFs and images, and the extraction of data of interest. So how's Effisoft different? We provide that intelligence layer that sits on top of the basic foundation of OCR and pattern matching. Think of these features and functions as an upgrade to your robot OS, providing enhanced vision and document processing capability. So let's see it in action. I've got a quick demo built here. Give me one sec. It looks like there we go. Okay, so let's go ahead and look at a couple things. What I like to do before I dive into the demo is give you kind of a quick view into the types of documents that we'll be processing. So I'm going to do 2 demos today, and I'll use UiPath because I have access to a VM that has them running. And in the first example, we're going to go ahead and process international invoices. Now, one of the challenges with these invoices is that they're variable number of pages. And if you look at the problem within the EU, the European Union, they've got a number of invoices coming from different countries. So not only do they have to classify the language as well as the extraction methods that they're going to use to pull off invoice number and invoice date, they also need to extract those different tables of data. So in this particular example, I've built just a really simple robot workflow here within UiPath, and I'm going to go ahead and kick it off. And the first step, just for simplicity, it's going to prompt me to pick a file, and I do that for ease of showing off the solution here. So it's actually going to go through its process, and we're going to do a couple things. This is actually the Effisoft scope. So I actually built out a scope, and just think of this as a container that you can put in place that can house activities that talk to Effisoft web services. And you can talk to an endpoint either in the cloud or on-prem. And in this example, just to show the data that I'm getting back from this particular process, you can see that I've already classified this invoice. So in this example, classification takes the form of identifying the country code where the invoice comes from. Remember, once we classify, now we can apply an extraction rule set based on that classification. So now I'm going to go and extract German terms because I've identified this as a German invoice. So it's going to continue through its process. And one thing I like to mention is that these Effisoft activities, there's some that are synchronous that'll go ahead and call web services and wait for a response. There's others that are actually asynchronous. So in this example for the data extraction, we actually initiated a get extraction or initiate extraction. And we actually pass the Effisoft server an invoice and say, hey, give me back a unique identifier for this process. And then we'll go ahead and wait for the results. So in this example, if I come down here to my, my right line or my output, you can see that Effisoft passed me back all the information from that invoice, the invoice number, the date, the purchase order number, the tax percentage, the net amount, all the different bits and pieces. Okay, so obviously now that information is available for the robot to use, whether they're taking that information and putting it into a system of record, or maybe doing approvals. Maybe I want to trigger a routing of that particular invoice for approval based on the amount. So I can do those types of things. And the final step is that the UiPath developers built some really neat stuff with their product where they'll actually, when they pass that invoice, we pass back the extracted invoice data table with the quantity, description, unit price, right into their data table function. So in this example, you can see now I have the data table information, once again, that I can use to validate or pass to another system of record. Okay, so that's my first example. Okay, really quickly, I went through, I called Effisoft web services. I did both synchronous and asynchronous calls to get back the classification, the header information from the invoice, and then also the invoice table. Okay, now the second example is a little bit different, and we do quite a bit of business in financial services. One prime example would be mortgage processing. So if you've ever dealt with any type of loan or a mortgage loan, they're quite challenging. Typically, there's a ton of paperwork involved. So this example is about a 40-page PDF that has a variety of files. Maybe the person applying put this in a scanner and shot it off, or took pictures with their phone and sent this packet over. You can see it's got a wide variety of document types. There's an affidavit, there's an application, there's a note, and these are all different length documents that are contained within this single PDF. So it can be quite challenging to process. In this particular example, I'm actually going to use that robot sandwich technique, and let me go ahead and stop that other workflow. And let's go into the mortgage. This one's quite simple. I'm actually enabling the robot with what's called an upload batch. Upload batch lets me upload a set of documents to a processing server. So take, for example, you've got somebody in the mortgage department. In this example, once again, I'm going to pick a file just for simplicity, but we could watch a hot folder, right? And we can watch for different files that come in. So in this example, I'm actually gonna pick that particular file. You can see it went really quick. So all this does is upload that file into a particular processor. It actually names that batch. And then on the back-end system within Effisoft, this server is going to sit and catch all those. You can see now I've got a new MorgoBot batch class. Its current status is new, but it's going to go through all these steps. The end result of this particular process, once again, just really simple, is that I've actually got an output. And I did this so I can show off some of the results of what we've done. And in this example, I've taken that big old PDF and I've ripped it into individual documents. So you can see now I've got the affidavit, the appraisal, the closing disclosure. Remember, classification and separation. This is a huge time saver in financial services. If you think of the bundled PDFs that get received on a daily basis that need to be managed and handled, just this step is a huge time saver. So not only did I output all these particular documents, but I've also got what I like to call a document fingerprint that goes with that batch or set of documents. This is more information than you could ever need, but it really opens you up to doing some really complex processing with your robots. We've got everything from the different documents, the confidence levels that we have on particular documents. We even go down to the page level. So you can see we actually analyze each individual page to make sure that those pages belong to that particular document, okay? And if I had extraction on this workflow as well, it would also include all the extracted metadata, all right? So I showed you a couple different demos. I showed you a direct connection to web services where we can get a closed feedback loop on classification or data from the document. I showed you asynchronous web calls where we can actually pass documents to the processing server, and either the same robot or a different robot can talk and get a status and get the data back. And then I showed you that robot sandwich, or kind of that disconnected workflow where we just hand off the work to the FSOF server, let it do its business, and then the end result can be picked up from an export folder or some other data format and continue on in the process.